Hey everybody, let's talk about one-step equations today. This is chapter 2 and it is lesson 1. The key is to just do the opposite of what you see. So if you see a plus problem like this one, then you just got to do the opposite. The opposite of plus is minus. So let me pull out my pencil here and let's go ahead and subtract 13 from this side. Rather than add 13, we're going to subtract 13 to get rid of that 13. If I subtract 13 from this side, I have to be balanced and I have to subtract 13 from the other side. So once I write that down, now I could actually do the math, or I could just pull up my trusty calculator because I don't want to do the math. I plop in the numbers 2, 7, minus 1, 3. That equals 14. And then I know that x, when I bring down that x, it equals 14. All right, here's the next one. Y plus 2 equals negative 6. I got a plus problem. I have to do the opposite. So I'm going to go ahead and subtract the 2. And that gets rid of this guy. If I subtract a 2 on this side, I have to subtract 2 from the other side. What is negative 6 minus 2? I bring my y down so that I'm ready to go. Y equals, all right. With my calculator, if I don't happen to know this in my head, then I would just go minus a negative, I would put in my negative 6 plus, or I'm sorry, minus 2, and that equals negative 8. All right, let's take a look at a subtraction problem. So now I've got things flipped around and I have the problem on this side and on this side. It doesn't matter. So I'm going to go ahead and try to do the opposite here. So if I have a minus 3 that I'm trying to get rid of, I need to do the opposite. So I'm going to go ahead and add a plus 3 to this side to get rid of it. If I did a plus 3 on this side, I must balance it out. I must put a plus 3 on the other side. Minus 7 plus 3. Oh, I can just, here comes my b. All right, with my calculator, I put in negative 7 plus 3 equals negative 4. Boom. All right, next problem. I have m minus 8 equals negative 14. I have this minus 8 here that I need to get rid of so that I can get m by itself. So I'm going to do the opposite. I'm going to add 8. Once I do that, negative 8 plus 8 equals 0, so that means that I have m left all by itself. When I add 8 to this side, I need to add 8 to the other side to keep things balanced out. Then I take my calculator and I go negative 14 plus 8 equals negative 6. And then I shoot my m over here. Ta-da. All right. That handles adding. That handles subtracting. We just always do the opposite. Well, when it comes to multiplying and dividing, same thing. We just do the opposite. But this is what they do look a little different, but it's still the same concept. We just do the opposite. The opposite of multiplying is dividing, and the opposite of dividing is multiplying. Here's the first problem. So I have 4x equals 6.4. So 4x is a way to say multiplying, right? So 4 times x equals 6.4. Well, I need to do the opposite. I'm going to go ahead and divide by 4 to get rid of that 4 because once I do that, 4 divided by 4, it equals 1, and then 1 times x equals x by itself, so x is alone just by dividing by 4. Ta-da, 1. Now, if I divide it by 4 on this side, I must divide by 4 on this side. Now, you can actually do that on a calculator and go 6 divided by 6.4 over 4, and it'll come out with a decimal, I believe. Oh, let me check. So 6.4 divided by 4 equals 1.6. Let's go ahead and just put that down as our answer. It's a pretty simple decimal. 1.6. Ta-da! All right, next problem. I have 10 equals 15x. Does it change when I just flip to the other side of the equal sign? Nope, same thing. I got to get my x all by itself. To do that, I need to divide by 15 because 15x means times, and we need to do the opposite, which is to divide by 15. 15 divided by 15 equals 1, and 1 times x is just x by itself, so that works. If I divided by 15 on that side, I must divide by 15 on the other side so that it keeps things balanced out. This means that x equals 10 over 15. Now, if you're savvy enough and you can reduce 10 over 15, by all means do that. I will accept x equals 10 from 15 from you at this point. But if I notice that both of those are divisible by 5. So I could go 10 divided by 5, and that equals 2. And then 15 divided by 5, that equals 3. And that would be considered the lowest terms. That is an optional step right now. 10 over 15 works for me. 19 equals r divided by 3. Same thing. Same thing, only now the opposite is multiplying. Since r divided by 3 is a division problem, I need to multiply by 3. So to do that, I would go ahead and put this here, and I would go 3 on the top. Now, when I multiply by 3, that makes that go away, and it becomes a 1, and that leaves the r by itself. If I multiplied by 3 on this side, I must multiply by 3 on the other side. Does anybody know what 19 times 3 is? If you, I just plopped it in my calculator. I am seeing that it is 17. So I'm going to go ahead and put r equals 57. I read it as 17, but it's actually 57. There we go. And the last problem that I have for you today, x over 4 equals -9. If I have a divide by 4, I need to multiply by 4 in order to get rid of it. That will take and get rid of the 4 on this side and get x all by itself. That's what I want. On this case, I need to go, if I multiply by 4 on this side, I must multiply by 4 on the other side. -9 times 4 equals -36. And that is it. All right, go ahead and do your